Hello everyone. Today we are going to discuss about polar plot in control system. Okay. So polar plot, it is a frequency response plot. Already we have discussed about board plot. Now it is a polar plot. After this plot, again one more frequency plot we will discuss, that is a Nyquist plot as per the university syllabus. Polar plot is a plot which can be drawn between the magnitude and phase angle of the g of j omega into h of j omega by varying the frequency from 0 to infinity. Polar graph, it consists of concentric circles and radial lines. This polar plot is a plot of magnitude versus phase angle in complex plane. Here we are taking magnitude versus phase in a single graph paper. Okay, when you are talking about board plot, there you have taken single paper only, that is a semilog sheet, but we have drawn two plots, magnitude and phase. But here we are taking only single graph paper and we are drawing only single graph, that is a magnitude versus as frequency varying from 0 to infinity. Okay, now we'll discuss about first advantage of polar plots. Polar plot depicts the frequency response characteristics over the entire frequency range in a single plot from 0 to infinity. This plot is much easier to determine omega PC and omega GC, phase crossover frequency as well as gain crossover frequency. So these frequencies, from this we can find even stability of the particular system. And another advantage in this polar plot is we'll have to work with only open loop transfer function g of j omega into h of j omega. When you are taking about board plot, we did not require here to convert g of s into h of s to the time constant form or any other. Directly you can go just convert and keep it as it is, whatever the transfer function. But it has one disadvantage. If the transfer function is having multiple factors, at that time this plot does not clearly indicate the contribution of each individual factor of the open loop transfer function. That is the main disadvantage of this particular plot. So coming to the basics of polar plot, already we have discussed about it is the magnitude of g of j omega versus phase of the g of j omega on polar coordinates as omega is varying from 0 to infinity. Okay. So here this graph sheet has concentric cells and radial lines. Concentric cell circles represents the magnitude and radial lines represent the phase angles. In polar graph sheet, so based on the angles, you know already clockwise and anti-clockwise. From 0 you need to take. If it is anti-clockwise, treated as positive phase angle. If it is clockwise, treated as negative phase angle from 0 degrees. To sketch or to draw the polar plot of g of j omega, that is a open loop transfer function for the entire range of frequency from 0 to infinity. So we need to know basically 4 key points. They are mainly, that is the starting point. You can say start of the point where at omega equal to 0 and the end of the plot, that is omega is equal to infinity, and the remaining two, one it is crossing the real axis, another one plot crossing at imaginary axis. Okay, if it is crossing real axis, that is imaginary part is equal to 0. If it is crossing the imaginary axis, real part is equal to 0. If you know these key points, easily we can draw the polar plot of the open loop transfer function. The actual procedure for drawing the polar plot. So first we need to express the given expression of open loop transfer function in 1 plus st form. That is the standard form of the first order generally. So substitute s equal to j omega in the expression for g of s into h of s, and we will get that is in terms of frequency g of j omega into h of j. So get the expressions for there is a magnitude and phase, mod of g into h and angle of g into h. So tabulate various values of magnitude and phase angles for different values of frequency ranging from 0 to infinity. We can take number of values. There is no limit here. So usually the choice of frequencies will be corner frequency and around corner frequencies. Okay. Choose the proper scale for magnitude circles. Fix all the points in polar graph sheet and join the points by smooth curve. Then and finally write the frequency corresponding to each of the point of the plot. If we follow this procedure, easily we can sketch the polar plot. Okay. Now let us take one simple example how to sketch the polar plot of the first order pole of 1 over s plus 2. We'll take first one simple example. So later in the next classes, so we'll take different examples. Okay. So first I have taken here first order, that is 1 over s plus 2. Given transfer function g into h is equal to, so that is a 10 by, it is not 1, 10 by s plus 2. Okay. So first step is we need to convert into frequency by substituting s equal to j omega. There we will get 10 by j omega plus 2. Then separate because it has a magnitude and phase. So separated magnitude, we need to find magnitude and phase. So mod of g of j omega into h of j omega is equal to 10 over square root of omega square plus 4. That is a magnitude. And angle of this transfer function is equal to, because numerator it has constant term, we will get only 0 angle only. So denominator we have j omega plus 2. So that is a tan inverse imaginary part omega by 2. Okay, that is a real part. So that is equal to minus tan inverse omega by 2. This is the angle of the given transfer function. Now in the next step, what you have to take? You have to take different values of frequency from 0 to infinity, including corner frequency. In this transfer function, corner frequency, when you are taking as a constant form, you will get the corner frequency. Just to take it as 2 outside, 1 plus es by 2. Right? So you will get here numerator, total transfer function 5 by 1 plus s by 2. Okay. So let us take here at particular frequency 0, infinity, in between different values also we can take here. At omega equal to infinity, magnitude you will get here. So that is 5. Right? So 10 by, directly you can take here 10 by root 4, because it is a simple problem. Without converting into standard also we can do it. 10 over root 4, you will get here 5. And angle it is, so minus tan inverse omega by 2. Omega is 0. Tan inverse 0 is 0. At omega equal to infinity, again magnitude, so that is a 0. 10 by infinity is 0. And angle is minus tan inverse infinity by 2. So minus 90 degrees. Okay. So now, so this figure shows that is a complete polar plot. Just you take these values When omega equal to 0, magnetism is phi, that is a plus phi, and at an angle of 0 degrees, that is on real axis only here. Okay, at omega equal to infinity, so magnitude is 0, but angle is minus 90, that is minus 90 angle here. So this curve, it is passing through this. Okay, it is like on semicircle. At omega equal to 0, magnitude is plus phi and angle is, and similarly at omega equal to infinity, magnitude is 0 and while angle is minus 90. Okay, just draw the curve, we'll get the complete polar plot of the given transfer function. Okay, in the next class, we will take some of the polar plots, that is a different examples by addition of denominator terms, you can say poles, and also when it is crossing real axis, when it is crossing imaginary axis, and how to find the stability from the polar plot. These topics we'll discuss in the next classes. Okay, is it clear? Thank you.